Welcome to this session. My name is Emir Köksal. I'm a professor doctor in the Department of Mathematics in 19 Mayıs University. We have 7 presentations in this session. First speaker is Nurhan Ibrahim. The title of the talk is Short-Term Individual Household Load Forecasting Framework Using Lstm Deep Learning Approach. The duration of presentation is 10 minutes, excluding question and remark. You can start.
Okay. Hey, can you see my screen? Can you see my screen?
Yes. Yes, we can see.
Welcome to the presentation of our paper titled Short-Term Individual Household Load Forecasting Framework Using Lstm Deep Learning Approach. For the speaker, I am Nurhan Mohammed Ibrahim. I'm currently working as a teaching assistant at Faculty of Engineering, Alexandria University in Egypt, and I'm a master student under supervision of Professor Ashraf Mujahid and Nabil Abbasi. So let's start our presentation. Introduction. Load forecasting is important in the development of smart grid systems. Load forecasting can be short-term forecasting if it spans 1 hour to 1 week, or it can be medium-term forecasting if it covers 1 week to 1 year, or long-term forecasting if it extends more than a year. Load forecasting can be done by a variety of methods. It can be classified into two main classifications: conventional methods or methods based on artificial intelligence. Conventional methods include statistical methods, such as multiple linear regression, exponential smoothing, and autoregressive integrating moving average. For the artificial intelligence-based methods, it can include support vector machines, artificial neural networks, radial basis functional network, and long short-term memory recurrent neural network. Most of the methods mentioned before are used for forecasting aggregated loads at system level, but load forecasting at building level is a challenging point of research as it requires forecasting unexpected consumption patterns due to the stochastic nature of the single household consumption. Accurate load forecasting for individual customers is needed for intelligent demand response methods to be used. And with the development of smart meter technology, large amounts of high-resolution data on energy use at customer level will be available. So this will help in more accurate load forecasting at building level. Also, the deep learning techniques, especially Lstm technique, long short-term memory technique, can produce acceptable results when used in short-term load forecasting at building level. So the objective of this paper to propose a short-term load forecasting framework using Lstm deep learning approach, the model to achieve higher accuracy, and the model can feed both aggregated loads or individual household loads. Our model is then tested using two different time series, one representing the aggregated load at station level, and the other represents the individual household at building level. The proposed framework flowchart, we started our work with load data collection from publicly available datasets. Then, these datasets is scaled using minimum-maximum scaler and divided into training dataset and test dataset. Actually, 80% of the dataset used to train the model and the 20% is used to test the performance of the model. Datasets are reshaped to be suitable for our Lstm model. Step 3, we implemented our Lstm model, and processed data from step 2 is applied in the proposed Lstm model. Step 4, proposed model is then trained with training dataset. Step 5, the proposed model is then evaluated using popular evaluation metrics. We use, finally, the proposed or the trained model to find the prediction for 24 hours ahead predictions of electrical load. Let's take a closer look on our datasets. As mentioned before, we use two datasets to evaluate our model. The first dataset is main power station load dataset. It resembles aggregated load dataset. It has historical data on ambient temperature and electrical load on single power station in Maine, USA. The data is collected at 1 hour interval for a whole year. The dataset contains 8,016 records for 2 features. The dataset is publicly available. The second dataset used is UCI Appliances Energy Dataset, and it resembles the individual household dataset. The data collection took place in a smart building that was outfitted with temperature and humidity sensors. It has historical data on electrical energy consumption of smart buildings, temperature and humidity inside the building in different places, and temperature and humidity outside the building. The data is collected at 10 minutes intervals for 5 months. This dataset has 19,735 records for 26 features. Also, this dataset is publicly available. As we mentioned before, we used Lstm network for our model. Lstm, it's long short-term memory. It's an excellent variant of recurrent neural network. It solves the problem of short memory and difficult training of recurrent neural network. It's very suitable for prediction of time series. As the figure shows, T is the time step, IT is the input gate. The input gate is mainly used to control how much information about the current state of the network to be saved in the internal state. It contains a forget gate. The forget gate mainly used to control how much information in the past state and needs to be discarded. And the output gate mainly used to control how much information of an internal state needs to be output to the external state. HT is the internal state of the current moment, CT is the external state of the current moment, XT is the external input of the current moment. So, Lstm recurrent neural network can control the retention and discarding of information transmitted in a neural network using the 3 gates as mentioned before. Determines how much of new state information at a certain moment or at the current time step needs to be stored in the memory unit. Compared with general neural networks, long short-term memory can learn dependencies with a relatively long span without the problem of gradient vanishing or gradient exploding. The proposed Lstm model. This figure shows the architecture of the proposed Lstm model. It consists of 3 Lstm layers stacked to create the deep learning network. The first layer, the input layer, receives the input matrix and updates the memory block for each complete input sequence. Following that, 2 Lstm layers are stacked in the upper layers. It gets the output from the bottom layer after learning from collected features. The top Lstm layers output are inputs into a standard feed-forward neural network, which maps the intermediate Lstm outputs to forecast energy usage for the desired time period. To avoid overfitting of the model, the proposed model has a dropout layer after each Lstm layer. Lstm model parameters. The hyperparameters tuning is important to enhance the performance of a deep learning model. In our model, the hyperparameters are based on the study of literature. The table shows the hyperparameters used. For the activation function, we used ReLU, model optimizer Adam, dropout rate 0.2, patch size 32, epochs 150, number of hidden layers 3, hidden unit size 128, and the loss function mean squared error. The evaluation metrics used to assess the performance of the proposed include mean absolute percentage error, root mean squared error, mean absolute error, and the equations are shown in the slide. The mean absolute error metric used or measures average difference between actual and predicted values, while root mean squared error metric measures the variance between the predicted and the actual values, and MAPE, mean absolute percentage error, represents the prediction errors expressed in percentage. Model evaluation, results and discussion. Our proposed model is implemented using Python and Keras library using Google Colab. Numerous scenarios are assessed for each dataset. We used 1 day look back and 1 week look back for each dataset to predict the following steps. Because data of UCI appliances are collected at 10 minutes interval, so 1 day resembles 144 time steps and 1 week resembles 1008 time steps. And for the main power station, it's collected at 1 hour intervals, so 1 day back resembles 24 time steps and 1 week back resembles 168 time steps. This table shows the proposed model performance for 24-hour ahead predictions. As we see, for the UCI appliances, 1 day back, the MAPE 20.546%, RMSE 57.178, and MAE 31.505. For 1 week back and same dataset, it gives 43% MAPE and 55.489 RMSE and 34.345 MAE. For the second dataset that resembles aggregated load, 1 day back, it gives 3% MAPE, 2.5 RMSE, 2.122 MAE. 1 week back gives 2% MAPE, RMS 2.2, and MAE 1.6. We can detect that the forecasting loads at the aggregated system level is more accurate than forecasting loads at the house level due to the volatility of the individual household. Let's see the figures. The figure on the right shows the actual and the predicted values of appliances energy usage using the proposed model on a random day in the test series. X-axis shows time of the day and the y-axis the energy consumption. We can see that the predicted values closely match the actual energy figures, as we can see from the graph. The graph on the left shows the actual and predicted values for main power plant electrical consumption. The model achieves high accuracy for both spikes and the troughs. Then, the results achieved with the proposed Lstm model in the paper is compared with other techniques previously published for the same UCI appliances dataset. As the table shows, our proposed model outperformed other methods on a competitive level. It also showed that the statistical methods, conventional methods like ARIMA, fails in prediction of load at household level. Conclusion, this paper presents a framework for individual residential load forecasting based on Lstm deep learning approach, since Lstm has been shown to develop long-term relationships. To avoid overfitting in the suggested framework, dropout regularization is used. The suggested framework's performance is shown using real-world energy consumption dataset for individual household. The suggested model's performance is compared to those produced using other techniques in the literature for the same dataset. The suggested Lstm model depicts the greatest predicting performance in general. Our future work, we suggest to utilize a hyperparameter optimization technique so we can enhance the proposed model performance. We can also combine the smart meter data and high accuracy individual household load forecast to investigate a novel framework for intelligent demand side management. Thank you.
Is there any question, comment, or remark? No question. Thank you very much for your presentation.
Thank you.
Next speaker is Muntean Angela. The title of the talk is The Priorities and Comforts of the Smart Home.
Hello. Just 1 second to share my screen.
Okay.
Okay, so I present to you the communication, the priorities and comfort of the smart home. This article contains a theoretical study which reflects the importance and priorities of smart homes in everyday life. There are some important priorities, such as the importance and priorities of smart homes in everyday life, a development in architectural design to promote comfortably controlled interior, efficient organization and control of living space, an ecological healthy environment. And the smart home, the human, with the help of small impulses, can manage the systems inside and outside the building, even remotely, which will determine the individual needs of human, the current priority in architectural design. Today's architects and designers in the design of residential and public construction apply the principle of functionality, but also the thermal, sound, technical comfort, accessibility, and speed to services and information, all ensured by the automation of technologies in the home. The smart home is a system of devices in the house that can perform actions and solve certain tasks without the participation of a person. The traditional Romanian houses of the peasants, the houses of our ancestors, classic houses, differ from today's smart houses, which were entirely made of simple but eco materials. Today successfully implemented in tourism, promoting culture, tradition, folklore, and national cuisine located in a local landscape. Today, traditional houses are complemented by intelligent systems. The evolution of the notion of smart home, a research topic for practical application, is historically followed and described in the collection of Essay vers une architecture toward a new architecture by the Swiss architect Le Corbusier, from which comes the term of modern architecture, with ideas for functionality and comfort in the interior space provided by some technology. Elaborating a first project, Villa Savoie, is a smart home, a stylistic concept developed by the architect, engineer, and painter Le Corbusier, and architect Pierre Gendret, a construction that represents a minimalist aesthetic of shapes that incorporates functionality. We consider it an inspiration from Japanese philosophy for interior space, free facade and openness to the natural environment. Aerated spaces unloaded of shop window furniture, a clear liner graphic of the interior design concept. Today will be like the contemporary stylistic of the 21st century, Japanese style, being a fusion between Scandinavian aesthetic and the simplicity and naturalness of Japanese style. Automated home technology in modern condition is an extremely flexible system that the user, and in the case of the elderly, build and configure independently according to their own needs. This assumes that each smart home owner independently determines what devices and where to install and what tasks and how they will perform. Smart home is a network of technologies and devices connected to each other via the internet, and the system priorities are to provide control, safety, and security to tenants, monitored and controlled remotely. The intelligent control system ensures safety, security, but also passive energy systems with the installation of thermal and photovoltaic panels, wind turbines of the beneficiaries depending on the package of services, today being suitable for private or office electric transport. Then the intelligent technologies provided by green electricity necessary for indoor comfort has a positive impact on the environment, as harness systems installed on the roof or facade of buildings, a current eco principle both for rural and urban areas. The many advantages of a smart home are the simplicity and speed with which we can control or carry out certain household activities directly from our smartphone or other device. But many of those who want a smart home with a controlled system can face several obstacles: high prices, attacks, and computer leaks, the difficulty of managing the system. And the smart home, the human, with the help of small impulses, can monitor the surrounding technique that will determine the daily needs of the individual, such as the system of regulation of heat and electricity brings benefit with large discounts on monthly bills. The ambience, the mood of the interiors can be changed by the colored lighting system. The play with the shape and size of the space changes by accentuating or diminishing some areas. Smart home services in the Republic of Moldova. Today in the 21st century, to benefit from the services and opportunities of a smart home truly automated, in the Republic of Moldova, we can turn to specialists in the field, companies that provide such services, meeting the consumer needs of the population for automated comfort in the house, which speeds up the development of science and technology, is complicated by minimal services or expensive costs, which seems unfeasible for low-income Moldovans. Therefore, in 2016, in Chișinău was launched a project in the field of the Internet of Things, the first housing block based on the smart house system in Moldova. The house system offers the inhabitants of the smart block the most modern level of services, as well as the possibility to use new tools for more efficient and convenient management of the houses, according to the latest trend in the field of information technologies and electronic communications. Thus, the basic component of the smart home installed in each block, security, video, access control, lighting, automation, and telemetry, will make the operation of the complex safer and more energy efficient. With a simple touch on the smartphone, user will control the light, temperature, doors, blind or curtains, the video surveillance system to be promptly informed about gas or water leaks, fire danger, or unsanctioned access to the house. Today, when humanity is going through the COVID-19 pandemic, we have all adapted to the requirements of isolation at home, and we have made communication, work, studies, purchase offers all remotely. Thus, smart devices have ensured our comfort and collaboration by remote control. The home, office, gallery, or shops have become spaces and domains of distant virtual digital communication, which ensures the stability and balance of human society in the 21st century, overwhelmed by the pandemic. The classic houses known so far will change its status into a smart home, being a traditional home for the near future. Change is inevitable, and services and technologies will become a new model of ordinary life, and like this, the smart homes will become part of our daily lives. Thank you for your attention.
Thank you very much for your presentation. Is there any question, comments, or remark? No question. Thanks again for your talk. Next speaker is Marin Zilewski. The title of the talk is Laboratory Model of a Pumping Station.
Hello. Hello, my name is Marin Zilewski. I will present you a paper, Laboratory Model of a Pumping Station. Pumping stations are facilities in the hydraulic engineering industry which serves for pumping water for a water basin or a source with a lower level to a water basin or a consumer with a higher level. Different pumping station systems are used in various fields, such as functioning of in garden complex, regulation of water level of natural and artificial water sources, and others. Level in pumping station can be controlled by a number of methods as follows: pressure sensors, level probes, ultrasonic devices, float switches, radar devices, and others. Each of them has own features that must be taken into account when choosing a variant for a specific practical application. Usually, appropriate instrument is used to indicate the start and stop level for a given water surface, and the task of the control system is to run the pump long enough to bring the water level to the required value. Generally, pumps can be driven by electric motors or by internal combustion engines, usually diesel. Electric drives are more efficient and can usually reach efficiencies of over 90%, depending on the type of motor used and its features. The analysis carried out shows that performance improvement of a pumping station could be achieved through the following main measures: appropriate pumps, high efficiency motors, accurate flow and level monitoring devices, programmer logic control system, and remote control. A type of pumping station and its control are described in this paper. To verify the proposed control approach, a reduced laboratory model of a pumping station has been developed on which the respective experimental studies have been carried out. The main purpose of a presented pumping station system is to control and maintain the water level in the respective reservoir by switching the pump in the pumping station. Figure 1 shows the basic components and indicators of a proposed technology group pumping station reservoir. The operation principle can be described as follows. The pump pumps water to the reservoir and fills it with water, which is distributed depending on the needs. It is necessary for the level in the reservoir to vary within certain permissible limits so that there is no overflow and spillage of water, nor to lower the water level in the reservoir to fall below any technologically acceptable minimum. The purpose of the control system is to maintain an optimal water level in the reservoir by switching on and off the pump in the pumping station. The pump aggregate can operate in automatic or manual mode. There is a switch on the control panel to select the operation mode automatic or manual. In the automatic mode, the pump is switched on automatically so that the level is maintained according to the task from 0 to 100%. In manual mode, the pump is switched on the start button and stopped by the stop button. From button, the pump speed can also be set when no operation mode is selected. In the pump station, a pressure transmitter is used to measure the water level in the reservoir, which converts the supplied pressure into unified electric output signal from 4 to 20 milliampere. Protective function must also be provided in the control system to prevent the pump from being overloaded or to defect. Digital inputs are used for voltage control, signaling or detected unauthorized access, as well as a selection of manual or automatic operation modes. The water level is set through a potentiometer mounted on the front part of the control panel, where the level in the reservoir is visualized by means of a switch from 0% to 100%. The pump must be switched off as 3% above the set value and switch on at 3% below this value. For this purpose, the respective hysteresis introduces in the control program. An alarm must also be displayed on the front panel for emergency upper and lower level in the reservoir. In the event of an emergency high signal, the pump must be stopped to prevent overflow. An operation voltage drop and the motor protection must also be signaled. In the developed laboratory model or stent, a DC motor controlled by pulse width modulation is used to drive a pump. For the control system, a suitable programmable logic controller with digital and analog input-output is selected. This control is wide type process with two different models. Some of the use inputs are related to current input from the operation transmitters is in 0. Another input is in 1. This is voltage input, which is set by the potentiometer. Digital input coming from the contactor voltage controller relay, digital input that come from a magnetic center contact, and others. Some of the used digital output are related with realization of pulse width modulation and signal of loss supply voltage and security and activation of motor protection and others. In figure 2 are presented the entire digital signals in the specific software. In the next figures are shown some parts of the developed ladder logic for operation of the pumping station system. Figure 3 illustrates the automatic mode of operation. For activation of this regime, the next conditions must be fulfilled, and this are checking the presence of voltage and checking the sender door security. This sender is mounted in the panel and control whether the door is open, but can also be a signal from the reservoir room and to monitor for unauthorized access. Checking the status of motor protection, checking where auto mode is selected, and checking the reservoir level in person. If the value is less, operation is permitted. Figure 4 presents the manual mode of operation with the same principle of activation as in automatic mode. Digital outputs are configured in the following lines of the program, shown in figure 5. Figure 6 shows pulse filling in PWM of implemented DC motor of the pump station. If none of the mounts is selected, the value of the type pump and stop pump button change respectively to up and down. Each press of a button changes the filling of the pulse by 5% or minus 5%. A variable M10 is written in a functional block. Figure 7 illustrates setting the hysteresis of pump operation. Figure 8 demonstrates the control of a pump from the ladder logic by adjusting the speed. In this way, the appropriate flow rate of a pump is selected. Figure 9 presents selection of a module for control and activation of the output Q0.0. The basis of the implementing ladder logic reduced laboratory model has been developed for testing of the pump station system in different regimes of operation. This model is shown in figure 10. The small expansion contains the pumping station and transparent PVC pipe is the reservoir. Next to the stand is placed the control panel to set both regimes, automatic or manual. The dashboard sets the water level in the reservoir, which must be maintained. The level status of the pumps works, does not work, and voltage control are also visualized. Figure 11 shows the dashboard contains the automatic fuse, power supplies, and control use. Figure 12 illustrates a shim developed with a DC motor drive that is controlled by PVM control. The circuit is implemented with ICTOP and transistor IRFP 4229. The output process for output of a process module have a voltage of 24 voltage, but with a small allowable output current. It is necessary to connect to the motor through a suitable electronic circuit to amplify the output current. The next figure demonstrates experimental download process of a control from the output. The next figure is presented an integrated circuit aided to improve the performance of the developed circuits. And the 15 shows figure 15 shows impulses from the oscilloscope of the motor with capacitor and diode. In conclusion, the main components and features of a pump staging system are presented, and its principle of operation is described. Based on the formulated requirement, appropriate programmable logic controller and electric drive are selected. The respective input, output, and output signals used are described, and a control logic for the diagram type is synthesis. Reduce laboratory model illustrates the practical application of the technical group pumping station receiver is developed. Some experimental results are presented and analyzed for different parameters and regions of the synthesis scheme. Thank you for your attention.
Is there any question, comment, or remark? No question. Thank you very much for your talk.
Thank you.
Next speaker is Lida Ibrahimi Wafai. The title of the talk is Roof Application of Solar Cells Angularly and Aesthetically.
Hello.
Yes.
Excuse me. No, is okay? Can you see?
No, we cannot see your screen.
Give me just 2 minutes, please. Now is okay?
Now, yes.
Okay. Hello, my name is Lida Ibrahim Wafai from the New York University. The solar cell application of the solar cell on the roof for the one house in Lefkosia.
Please pay attention to the duration of the presentation, okay?
Okay. Now, what is about the temperature of the Cyprus? Generally, it's very high temperature, and it's better to use the solar energies or with solar cell. When we check it, you know, the average maximum temperature for each month, we can see, you know, the temperature is very high, generally in winter and summer, again, in 4 Celsius. Why, you know, we use, you know, solar cell just for thermal comfort is very important in the buildings. And every time, you know, in the cost for the electricity, it will be increasing, and it is better to use the renewable energy sources. Okay, I will check for all about the PV components, PV design, system cost, system performance, system simulation and software, and with calculations. The systems, off-grid system, we have 2 systems, on and off-grid systems, but off-grid system is very, very economical. And we check for just for off-grid systems. on-grid systems, just we can send to the network. But this off-grid system is very easy to use. Why, you know, solar cell is better to use? Because, you know, sun, you know, is one kind of the renewable energy. Lifetime is infinity. Environment friendly, is very, very economical. But when the number of the factories will be increasing, it's better, you know, if you compare with the before years. And we can hit a trans, but here when you check it for the Cyprus, generally now is a new technology. We use solar cell or something in the Cyprus, but in this country is no petrol, no coal or something. It is better to use generally from wind energy or solar energy for product electricity. Okay, what is the main components of the PV systems? PV systems is a solar panel, charge control, inverter, and battery. This is a solar cell. We will have any size or efficiencies depending to the efficiency of the solar panels. It's not the same, it's dependent against the factories, you know. But material, generally, they use silicon and germaniums. It's a semiconductor. This is a charge control for check the just charge. The another one inverter, because when after we product electricity with, you know, solar cell is a DC current. After that, we must be changed to the AC. For use, you know, any devices in your house. And about the batteries, batteries is good for the save the energy when after the sunset, but we need it for extra place. If we have a chance to send to the network is better if you compare with when you want to be safe inside the battery. This is an off-grid solar PV systems, and they show the schematics of here. From the, you can have a two chance to save after the sunset. You can use it against, you know, solar energies, you know. But for batteries is DC. After then you can send to the inverter and change to the AC against, and you can use for your house. Now, again, you know, they show the design of the chart for the solar panels. When you use solar panels for product electricity, is a schematics of the what this design. In the second, but when you check it, the angle for the solar cell is very, very important. This angle you can use any calculations or any equations. After that, you can decide what is the angle, theta angle, but it's dependent to the climate of your city. We must be check and calculate best tilt angle for which one is okay for your climate. Here we will check for the man houses in the Lefkosia about, for example, if houses they use light, TV, or refrigerator, or some more water pumping or something. About the power, but how many hours operating time we have. After then, directly we can calculate what is the direct energy, okay? Power multiplied by time. We can calculate the energy. And they show for the small houses, for one house in the Lefkosia, what is the total power. And again, you know, about food energy is the 9.255 kilowatt hour per day. But this is not, you know, before how many months before you will check it, you know, and change to the Turkish lira, 1.31. After then you can change against, you know, to Turkish monies, you know, and for each month, how much money you must be paid. System voltage, they show here, what is the, for 1 kilowatt and treat until the region is there 35 kilowatt hour. And this is output, we accepted, I want to be using 275 watt output for one solar cell, and they show here what is the maximum power. And open circuit, again, you know, we use all this data directly from these tables, okay, for which one? For 275 watt, then is the power is 275. Okay, but after then we have a what? Solar panel for size, we have a losses, is the solar charge controller. When we calculate that, and we can edit to the total energy per day, we can calculate the energy. After then, against panel generation factors is 77%. After the calculate all, we can find we need it for how many panels? We need it for the 8 panels there. And 3 more, because from 338.1 from the table, you can put it there. But 3 strings multiply 3 panels in the every string. We need it for what? 9 panels, okay? 9 panels multiplied by the watt for each panel is 275. You can calculate what is the power, 2,475 watt. This is a forward charge controller. And they give it here the high efficiency. Now we have a good, you know, against, you know, for charge controller efficiency, about 92, 98%. And is very, very perfect for what when the efficiency is very high. It's good for cold weather and cloudy or Z days. And the batteries against, you know, is deeply discharged for any region. Then we can check what is the current against 33.37 for charge controller. And we decided, you know, we will use a solar charge control 35 ampere and 24 volt. For inverter against, we must be decided before the design. For change the DC to AC. After then for the inverter, if we will check it, the efficiency, we accepted 90%. And we will find the sum, choose about, it is better we choose what? 2 kilowatt inverter. And against for battery banks, we can check against, we have a 2 type solar batteries there. And after the check for the batteries, we know that about the energy conservation per day, 9,252 watt hour is the energy. There is we have a losses for inverter, generally 10%, approximate 10%. After that, you will be fine. What is the battery voltage is 24 volts. After that, you will be fine. What is the battery's capacity? Battery efficiency, against, you know, all battery losses is 50% and efficiency about 85%. And the battery capacity divided by together, we can find 498.88 ampere hour. And they show here all the solar system batteries. And divided by, when is the 50%, we have what happens, you can find what is the 1,000 ampere hour after the calculations. We need it for the 5 batteries in the bank, every one have 24 volt and 200 ampere hour, and connected them together in the parallel. Battery bank output is 24 volt and 1,000 ampere hour. Okay, this is a backup generator. They show we can choose 2100 watt generator, like the inverter. And here they show we needed to ground. Well, the same, we must have a ground wire. And for after the find what is the solar cable selections, we need it for 4 millimeter square is available in market. We can find the in market, okay? And cable area is 0.836 millimeter square. And solar protection fuse, we needed the fuse against. And after we check it against for string fuse current is 40.46 ampere. We can choose, the ampere. And circuit and mounting, they show here how you can battery monitor. And again is about the design and the cost and simulations. When we check it there, we can check it for the payback period, cost over saving. And we know that from before, we need it for the energy per day, okay? And it's changed to the Turkish lira. And we can calculate energy over year. Multiple by 12 months, we can calculate. And again, the total amount for the elements, we ask how much is it for each one. When you have a total of this one, you can find in the Turkish monies. And payback period is cost over saving about 2.4. After this, we have about generally after 3 years, maximum 5 years, okay? We have amortiz if you want to use the solar cell, but again, this is dependent to what? It's dependent to the efficiency of the solar cell. Factories, which factories, because okay, lifetime for the solar cell generally is 30 years, but batteries 10 years, for example, but all is not the same. It's dependent to the kind of the production, that's all. Efficiency, maybe they wrote is good efficiency, but after that, maybe after the 5 years or 6 years, it will be finished. This is a simulation of the, for the, again, in the Lefkoşa, to any data inside. And here, generally, you can check it for the solar angle, for the near, approximately, if you write inside what latitude data for your city, not bad, you can use generally for Cesium, but it's dependent to the families inside. Why? Because maybe the family, if you want to be checked for the families inside, maybe they like generally for the buildings is cooling or maybe heating. Is dependent, but it's a fix. Generally, you can choose near the latitude data, and you put it any data inside the simulations, and you can calculate all during for the Lefkoşa for one house, but you can write for all because you can change the angle is inside, and you can find what best angle for Cyprus climate, Lefkoşa climate, but generally it's the same for Magosa or something, just approximately is the same data. PV panel is very good for what, because directly we use the renewable energy. You don't need for pay monies, extra money for government, no tax, nothing. But first money is expensive. After then is good. And again, these systems, on-grid systems is perfect because you can use it directly for your house. But lifetime generally for batteries is not good. If you have a chance to send to the network, it's better. Thank you very much.
Thank you very much for your talk.
Thank you very much.
Next
Any
speaker
questions?
is, yes,
It's okay. Thank you very much.
thank you. Next speaker is Shahzoda Anarova. The title of her talk is Calculating Boundaries in Methods of Determination of Fractal Dimension. But she's absent, I think. Okay. The last two presentations will be given by Lamir Shurkti. The title of the first talk is IoT-based indoor air quality monitoring systems to improve the health of students in gymnasium prison. The title of the second talk is Albanian News Category Predictor System using a multidimensional naive base and logistic regression algorithms.
Yes, hello.
Hello.
Can I share my screen now?
Sure.
Can you see my screen?
Yes. Now, yes.
Okay. Hello, I'm Lamish Kutli. I'm a PhD student at Southeast European University. I am pleased to present Albanian News Category Predictor System using a multinomial naive base and logistic regression algorithm. This is the outline of the presentation. I'm going to start my presentation with a short introduction and then explain the methodology of our system. I will continue by showing our developed system and finish my presentation with some results and conclusions. Today, we have more text data than ever before. This data comes from various online sources, such as news portals, social networks, digital books, websites, emails, etc. And extracting data from these sources can be difficult and time-consuming. What is text classification? Text classification is the process of assigning a labeled category known as a class to text. Nowadays, the text classification has many applications, such as question answering, spam detection, sentiment analysis, and classification of articles in the news. Here, I have three examples. We see the classification or categorization of news, which can be sport, politics, technology, entertainment, etc. Classification of emails can be spam and not spam. Classification of product reviews can be positive and negative. For large data set, machine learning systems are often very efficient and classifying text. Classifiers algorithm can be used for text classification are naive Bayes algorithm, logistic regression, support vector machine, neural network, KNN, etc. Here we see the text classification general process. The first process is desired text. Next is transform the text to vectors or numbers, then feed the data to the model. After that, set prediction criteria once the model to converge, and finally we will get the output of the class. Here is our methodology. We can to classify new articles into specific categories. We use data set from Kaggle website. Here is the link, and the data set contains over 3 million news articles with a covered period from 25 September 2007 through 27 of August 2020. taken from this news page, gazetaexpress.com, insideri.com, gazetablitz.com, balconi.info, indexonline.net, clankosova.tv, calzo.com, lime.net, telegraphy.com, and kungoli.com. The columns included in this dataset are the content of the article, date, title, category, author, and source. From this dataset, we filtered or we extracted the news of the 2020 year by the following categories. We get sport category, technology, politics, lifestyle, health, fun, economy, region, entertainment, and world. The result dataset consists 10,223 articles. Here is our methodology. In this table, we show the categories, count, and the percentage of news extracted from dataset. To develop our system, we use the Python programming language and the Flask web framework. First, we import the content and category column from our dataset. After creating a stop word list, we remove common words. After that, we split the dataset in 17% to train and 30% to test. After that, we transform the text to vectors using the TF-IDF vectorizer, which vectorizes the content column and give a unique numerical value to every category. We vectorize and using a label encoder. After that, we implementing a multinomial naive Bayes and logistic regression classifier to training the data. And finally, we save the models in the people files to make new prediction later without train the model. Here is our website or system to classify user documents. We developed this application, and the system has a text box to place the text and two buttons. After clicking the button classify the content, the system classifies the placed text and shows the news category to which it belongs. In this example, the prediction is sport. Here is the result of a multinomial naive Bayes classifier. Here we show the accuracy score is 82%, recall score is 82%, precision score is 85%, and F1 score is 81%. In this figure, we see the confusion matrix derived from the multinomial naive Bayes classifier. From the matrix, we can see the economy category consists the highest classification, while the lowest classification has the category technology. In this slide, we show the results of a logistic regression classifier, and here we see score is accuracy score is 86%, recall score is 86%, precision score is 87%, and F1 score is 86%. In this figure, we show the matrix derived from the logistic regression classifier. From this matrix, we see the economy category consists of the height classification followed by entertainment category, while the lowest classification has the category technology. Here we see the conclusion and the future work. Your system can be used to classify Albanian language news using the multinomial naive Bayes and logistic regression algorithm. Logistic regression model is more accurate than the naive Bayes multinomial model. The model multinomial naive Bayes achieves 83%, but logistic regression achieves 86%. The naive-Bayes multinomial model is faster than the logistic regression model, especially when the dataset is large. In the future, we plan to use other classification algorithms, and the entire classification Kosovo news article dataset will also be used to achieve the results. Thank you for listening to my presentation.
Any question? Any question? Comments or remark? No question.
Can I present next?
Right. Right.
If it's possible, I want to start this presentation, but I record the audio for this presentation.
The title of our study is Internet of Things Based Indoor Air Quality Monitoring System to Improve the Health of Students in Gymnasium John Buzuku present. I'm going to start my presentation with a short introduction and then explain the methodology of our system. I will continue by showing our developed system and finish my presentation with some results and conclusion. Air pollution was responsible for 6.67 million deaths worldwide, accounting for approximately 12% of the global total. A study conducted by the World Health Organization has shown that out of 1,000 total deaths in Kosovo, 6 are due to air pollution. Air pollution has numerous negative impacts, mainly related to lung diseases, respiratory, cardiovascular diseases, and lung cancer. We spend about 90% of our lives indoors, and it is important to check the air quality for better health. Students also spend of their day inside the school, and the majority of air exposure occurs indoors. This can negatively affect their performance and learning. In our schools, the importance of measuring air quality is not as important as in some developed European Union countries, which is also affecting the health of students. This system will provide information to the school and help raise awareness among the school community and provide a solution to improve the problem of air pollution at a low cost and low energy consumption. The aim of this paper is to monitor air quality in some classrooms of Gymnasium John Buzuku Advanced Secondary School. This proposed system will collect air quality information via sensors using Internet of Things. The information collected will be able to be monitored from anywhere via the web and smartphones in real time. In this slide, we have described our methodology. The data are collected from sensors which have installed in Gymnasium John Buzuku School. The sample is selected in one class to monitor air quality. We have installed indoor air quality sensors nodes at school, and 1 week we collected data during the learning process and 1 week after the learning process ended. Data collected are analyzed, and we test the difference between periods for students present in a class and where the lessons ended. Also, we analyze the relation among all variables and the test. We designed a sensor notebox and printed it with a 3D printer. We placed in this box the MKR 1000 board, PMS 5003, CCS 811, and THD 11 sensors and battery. This slide shows our developed system. Our system will collect indoor air quality information via sensors using Internet of Things and save it to the database using the web API. The collected information will be able to monitor from anywhere via the web and smartphones in real time. A web application also was developed which would enable users to monitor data from anywhere via the web and smartphones, while having the possibility of monitoring data weekly, daily, every 3 hours, and 30 minutes in a table and diagrams. Web application and web API developed with PHP programming language, while database with MySQL. The figure showed the graph and the collected data in 3 hours period for temperature. Table reports the data of our study. The descriptive statistics, minimum, maximum, mean, and standard deviation values are used. In total, we have collected 8,608 observations for 14 days period. In this table, we show minimum, maximum, mean, and standard deviation for temperature, humidity, particulate matter 2.5, particulate matter 10, and carbon dioxide and total volatile organic compounds. Based on indexed air quality rating index, temperature mean showed the level was inadequate during this time. Based on standard levels of humidity mean showed the level was poor. Particulate matter 2.5 mean showed that the level of particulate matter 2.5 was fairly good. Particulate matter 10 mean showed that the level of particulate matter 10 was good. The mean of carbon dioxide showed that carbon dioxide was fair, neither good nor poor. And total volatile organic compounds mean showed that the total volatile organic compounds level was 7. In this slide, we show correlation analysis. Temperature is significantly and negatively correlated with humidity and positively with carbon dioxide. That means if the temperature increases, the humidity will decrease and vice versa. Humidity is positively associated with particulate matter 2.5, particulate matter 10, and negatively with carbon dioxide and total volatile organic compounds. Particulate matter 2.5 is positively related to particulate matter 10 and negatively related to carbon dioxide and total volatile organic compounds. Particulate matter 10 is negatively correlated with carbon dioxide and total volatile organic compounds. Finally, carbon dioxide is positively associated with total volatile organic compounds. To test the differences on air quality parameters between days when students present in a class and where the lessons ended, we have used the independent simplicity test. Science, the value of the signifier is 0 for each of the parameters, and science, the value of signifier is less than 5%, then it means that we have differences between them. The results show that our system can be used for indoor air quality monitoring and is low cost and low energy consumption. Descriptive statistics show that the indoor air quality has been very poor in gymnasium during these 14 days, according to intervals suggested by Institute. When students are in the classroom, they open the window, and in the classroom there are a high level of fine particulate which are mainly introduced indoors by highly dilated outside air. In the house, when students are not in the classroom, the windows are closed, and in the classroom, there are a high level of carbon dioxide due to the accumulation in the classroom and inadequate ventilation. As accepted, the temperature level is higher when windows are closed. The humidity level was higher when students were at school because they have opened the window and fresh air has presented inside. The level of carbon dioxide has been lower when students were at school. This means that carbon dioxide has got infiltrated when windows have been opened and index air quality has increased during this time. The total volatile organic compounds has also been lower when windows have been opened. We recommended that the school use ventilation to keep fresh air to help students perform better in the class. As a future work, we will look at the school documentation. How many students are sick in this class during this year being affected by polluted air?
Yes, I finished my presentation.
Thank you very much for your presentation. Is there any question? Comment? Or remark? Thanks again. And thank you very much for your participation to this session. Now I'm ending up this session, wishing to meet in other sessions.